Hi, this is Glenn Langston again from the U.S. National Science Foundation, and I'm actually now going to show you the computer parts of your radio telescope that you're going to need to go with the feed horn you've already built now. So the signal actually comes into, well, it comes into a computer, and we found you can certainly do this on your own laptop. We found the software is such a sort of fiddly thing. Plus, you can't leave your laptop outside, which is what we want to do to allow you to do your observations day and night. So we actually recommend using either this Raspberry Pi 4B with 4 gigabytes of data and a fan. And this one has a GPS, which is valuable but not required really for this project. But you're going to plug in one of many great software-defined radios. The cheapest one is this RTL SDR dongle, which has 50 dB of gain, which is a lot of gain. It basically means multiply by 100,000. And this has a certain bandwidth of 2.4 gigahertz, which is good. We could definitely use more, and it also has kind of a funny bandpass, but it's by far the least expensive of the dongles we recommend. There's another excellent one called an AirSpy, this is the mini one, and this is plenty for studying the Milky Way. This one is about $100, has a 6 megahertz bandwidth, and is good gain capabilities, and is good if easily attaches to your computer. So when we put this stuff together, we actually tend to, if we want to observe day and night, you have to put your computer in a weather-tight box, which is what I have for my various telescopes. This is, not too expensive. It has an Ethernet connection because I use only power over Ethernet to run these telescopes. And you need a power over Ethernet dongle, which of course we have. And you need a power over Ethernet router, which is actually remarkably good price and also has the feature. So this is one, there's many of them. It has two unpowered connectors here and 4 powered connectors. So you can, if you want to expand your telescope empire, you can power 4 telescopes with this thing. And that's good for a number of scientific reasons. But so you need one of these, and this is only a little bit more expensive than the power supply for your Raspberry Pi. And if you power 4 of them, then it's actually cheaper than the power supply because it's about $35 at least currently. Now, a more modern version of the Raspberry Pi is a little bigger, which is both good and bad. It's actually this 400 version of it. If you can see it for a second, it comes in and out of focus. And it uses exactly the same software as the 4B does, this guy. And the software is actually, it's both great, interesting, and it's kind of a nightmare. So it's like hard to get everything set up correctly. So it turns out we've done that for you. So this little SD card, you go to our website where we have these different versions of the operating system, get the latest one, and you program this with your laptop or whatever computer you have, and then you put it inside of your Raspberry Pi, and boom, you're ready to start your astronomical observations and the data analysis and everything. So those are the pieces of the control system. Of course, you need a bunches of Ethernet cable to be able to connect your telescope and move it around, and we'll show you that in a second. But anyway, that's the basic idea of how it works. So again, this is Glenn Langston with the National Science Foundation, and now that I've shown you the parts, we're going to put them together.